The Cenozoic era dawned as a profound biological power vacuum, following the abrupt collapse of non-avian dinosaur dominance 66 million years ago. This transition from Mesozoic stability to Cenozoic niche availability provided an unprecedented opening for terrestrial vertebrates to reclaim the apex predator role. While mammalian lineages began their ascent, the Phorusrhacidae emerged as the most aggressive avian attempt to secure this position. These creatures were not the monsters of popular myth, but rather a calculated evolutionary response to a landscape suddenly devoid of its previous masters. The strategic pivot of the Phorusrhacidae is defined by a radical morphological transition, the shift from flight-capable ancestors to specialized, flightless terrestrial predators. By abandoning the metabolic and structural costs of flight, these theropods redirected their biological energy toward robust skeletal architecture and predatory efficiency. This specialization allowed them to exploit the South American continent's isolation, creating a unique evolutionary laboratory where they could refine their predatory mechanics without immediate interference from northern competition. By focusing on vertical stance, powerful neck musculature, and specialized cranial structures, the Phorusrhacidae effectively re-engineered the avian form to dominate the terrestrial food chain, marking a distinct, high-stakes experiment in post-extinction ecological reclamation that would persist for tens of millions of years. South America, isolated by vast oceans during the Eocene, became a unique evolutionary crucible. This geographic insularity prevented external competition, allowing endemic lineages to experiment with novel ecological roles. Within this context, the Phorusrhacidae, or terror birds, began their ascent, not as immediate apex predators, but as smaller, specialized forms adapting to specific niches. Their early development illustrates the logistical challenges of transitioning from flight-capable ancestors to terrestrial hunters in a competitive landscape. The earliest potential Phorusrhacid, Paleocoelopterus, emerged around 53 million years ago in the Eocene. Standing approximately 1 meter tall, comparable to a stork, it was a slender, agile bird adapted for navigating dense Brazilian forests. Its long legs facilitated swift pursuit of prey, yet it was far from an apex predator. That role was occupied by larger crocodilians and snakes. A later, more definitively identified Phorusrhacid, represented by a tibiotarsus bone from Argentina dating to 43 million years ago, further underscores this humble beginning. This fragmented fossil indicates a bird weighing only about 5 kilograms, reinforcing the notion that early Phorusrhacids were more bird than terror. These diminutive early forms faced an intense arms race within their ecosystem. Evidence from tooth marks on the tibiotarsus suggests it was preyed upon by contemporaries, potentially hypercarnivorous marsupials like Neolests. This early competitive pressure from established mammalian and reptilian carnivores meant Phorusrhacids initially occupied a lower trophic level. South America's isolation, while protecting them from northern competitors, simultaneously forced them into direct, high-stakes competition with its own diverse and formidable fauna. This challenging environment, rather than immediate dominance, shaped their initial evolutionary trajectory, laying the groundwork for future specialization. How does a terrestrial avian architecture scale to apex status without sacrificing mechanical efficiency? By the Oligocene, the Phorusrhacidae solved this through extreme giantism and specialized cranial engineering. Physornis represents a critical milestone in this transition, weighing up to 240 kilograms. It surpassed the mass of any modern ostrich, rivaling the scale of a grizzly bear. Its primary tool was a massive, hooked beak often described as a bolt cutter. This was more than a simple biting apparatus. The evolution of the terror bird skull type introduced a rigid, reinforced structure capable of withstanding immense vertical stress. This allowed the bird to use its head as a biological axe, delivering high-impact strikes that could cleave through hide and bone with clinical precision. The Miocene epoch further refined these predatory logistics, forcing a divergence between raw mass and high-velocity pursuit. Brontornis utilized a heavy-set architecture, reaching weights near 400 kilograms. Its robust skeletal frame suggests a strategic trade-off, sacrificing top-end speed for the structural integrity required to grapple with large megafauna in ambush scenarios. Conversely, Kelenken optimized for the pursuit niche. Standing 3 meters tall, its anatomy featured elongated lower leg bones, enabling speeds exceeding 48 kilometers per hour. This mechanical advantage allowed Kelenken to outrace contemporary mammals, effectively turning the open plains into a high-velocity kill zone where evasion was statistically improbable. To manage this physical output, the family evolved a sophisticated sensory suite. Forensic audits of their brain cases reveal highly developed optic lobes and specialized inner ear structures. Their vision was optimized for high-contrast detection, functioning effectively across varying light levels to maintain a constant operational window. More critically, their hearing was tuned to low-frequency vibrations. This allowed them to detect the acoustic signatures of prey hidden in undergrowth or the rhythmic thrum of distant herds long before visual contact. By integrating these sensory inputs with specialized beaks and divergent locomotion strategies, the Phorusrhacidae achieved a morphological peak that dominated the South American landscape. This specialized architecture, however, would soon face a continental-scale stress test as geographic barriers began to dissolve. The formation of the Isthmus of Panama served as the ultimate stress test for the Phorusrhacidae, marking the transition from isolated continental dominance to a volatile, integrated ecosystem. The Great American Interchange forced a direct confrontation between the specialized southern avian predators and the diverse mammalian carnivores of the north. This was not a singular event but a prolonged period of competitive displacement. While the southern ecosystem suffered significant faunal turnover, the Phorusrhacidae demonstrated surprising resilience through the genus Titanes. As the only large South American predator to successfully establish a foothold in North America, Titanes serves as a primary case study in migratory success. Its presence in regions spanning from Texas to Florida indicates a high degree of ecological flexibility, allowing it to compete alongside established northern carnivores like saber-toothed cats and bears. However, the broader decline of the family suggests that successful migration was the exception rather than the rule. The competitive pressure exerted by the interchange was asymmetrical. While large-scale predatory competition was intense, the most disruptive influence on the terror bird population likely originated from smaller, more versatile organisms. The influx of northern omnivores, particularly procyonids, introduced a new layer of ecological stress. These smaller, highly adaptable mammals likely targeted terror bird nests, consuming eggs and juveniles with a frequency that the specialized, slower-breeding avian giants could not mitigate. This shift in competitive pressure, where small, opportunistic omnivores proved more lethal to the long-term survival of the family than the large mammalian carnivores they had evolved to fight, highlights a critical vulnerability in their reproductive strategy. By the time the land bridge was fully operational, the Phorusrhacidae were already navigating a complex decline. The interchange did not trigger an immediate collapse, rather, it accelerated an existing trend of fragmentation. The resilience shown by Titanes in the north provides a stark contrast to the rapid contraction of southern populations, suggesting that the terror birds were not universally outcompeted by northern arrivals. Instead, the interchange acted as a final, compounding factor that tested the limits of their specialized predatory architecture. Their inability to adapt to the changing demographic pressures of the late Cenozoic marked the end of their long-standing tenure as the primary avian experiment in terrestrial apex dominance. How does a specialized predatory dynasty finally conclude? The closing audit of the Phorusrhacidae reveals a tactical retreat, shifting from apex dominance to specialized survival through significant size reduction. Late Pleistocene finds like the 13-pound Eschatornis indicate a lineage clinging to niche roles long after their morphological peak. Chronological data remains uncertain, evidence suggests survival until 18,000 years ago, making human-era overlap a distinct possibility. Ultimately, the terror birds represent a highly successful, albeit temporary, evolutionary strategy that functioned for 60 million years. Their legacy highlights the inevitable friction between specialization and environmental shift. Our world is beautifully diverse, keep exploring.